Greetings! Welcome to Pablo Hidalgo's tutorials and my free CCNA Complete course. Today I bring you lesson number 2, TCP/IP stack and OSI module. In the last video, we began the topic of protocol stacks or protocol suites. Let's remember that a protocol suite is a set of protocols that work together in order to provide network communication services. The Internet Protocol Suite, or TCP/IP, is the most common and important protocol suite used today. The TCP/IP protocol suite is an open standard protocol suite created and maintained by the Internet Engineering Task Force, or IETF. It is a stack of 4 layers. These layers are application, transport, internet, and network access. A reference model is a framework to help us understand and implement the relationships between different protocols. Also, the model provides us of a common language that we will use to describe the network functions and capabilities. The OSI reference module provides an extensive list of functions and services that must happen at each layer. It's a stack of 7 layers. These layers are Layer 7, Application, Layer 6, Presentation, Layer 5, Session, Layer 4, Transport, Layer 3, Network, Layer 2, Data Link, and finally Layer 1, Physical. Both the TCP/IP stack and the OSI model are commonly used when referring to networking protocols. In the OSI model, the network access layer and the application layer of the TCP/IP stack are divided into more layers to describe the functions that must occur at these layers. The TCP/IP application layer is divided in layers 5, 6, and 7 in the OSI model. Also, the OSI model separates TCP/IP network access layer in 2 layers, data link and physical. The original TCP/IP stack divides the networking functions into 4 layers, while the OSI module has 7 layers. On both cases, the top layer focuses more on the applications that needs to send and receive data, while the lower layer focuses more on the need to transmit the bits from one device to another. For this course, we're going to use a hybrid 5 layers model. This model is constructed using the application and transport layers from the TCP/IP stack and the network, data link, and physical layer from the OSI model. Notice that this 5-layer model is the one the most used today. A single communication, such as a video or an email message with a large attachment, could be sent across the network from source to destination as one huge uninterrupted stream of bits. This would create problems for other devices needing to use the same communication channels. These large streams of data would lead to significant delays. Even worse, if any link in the network infrastructure fails during the transmission, the complete message would be lost and would have to be retransmitted in full. A better approach is to divide the data into smaller, more manageable pieces to send over the network. Segmentation is the process of dividing a string of data into smaller units for transmission over the network. To be transmitted over the network, the data generated by an application must travel down along the protocol stack, starting from the upper layer until it reaches the lowest layer. Each layer receives the data from the layer above and adds its own header. The data link also adds a trailer. This process is known as encapsulation. The data unit, along with its headers at any layer, is called a Protocol Data Unit, or PDU. The following are the names of the different PDUs. First, we have data, is the general term for the PDU used at the application layer. Next, we have segment, is the transport layer PDU when we are using TCP. We also have datagram, is the transport layer PDU but when we are using UDP. Next, we have packet, is the network layer PDU, for example IP packets. Next, we have frames, is the data link layer PDU, for example Ethernet frames. And finally, we have bits, it's the physical layer PDU. It's used when physically transmitting data over the media. De-encapsulation is the process used by a receiving device. The data is de-encapsulated as it moves up the stack toward the end user application. As each layer receives the data from a lower layer, it processes the header for that layer. After processing the header is removed, and the remaining portion of data is handed off to the higher layer protocol until it reaches the end user application. You may follow me on Twitter and also on LinkedIn. And please subscribe to the channel if you are not already a subscriber. For our next lesson, I will present to you the physical layer, and we will begin with copper UTP. Thanks for watching. See you in the next lesson. Goodbye.